Okay, so we're going to go ahead and do the setup of an ECMS 32. Now, why do we call it an ECMS 32? Well, because we can take in 32 channels of electric machine. So each channel is 3 phases of voltage and current. So a channel takes in data from an E-plug. So we're going to cover what comes with the different types of kits. So I have 32 channels coming in here, Cat 5e, Cat 6 on the back. I have the cord, the Cat 5 or Cat 6 that will go to either, well, we usually use a local PC that will connect to this so that it creates a buffer with the rest of the system. But we're going to go through all that. Matter of fact, we're going to demonstrate version 9, and I haven't played with this latest beta. It's supposed to be the final beta before release. Also, the power supply is built in, so this will come with a cord that connects to it. So you need 120 volts in, however that comes in here. And then you have this. That's basically it. This is signal conditioners with a multiplexer that staggers through each of the 32 channels. Now, unlike an ECMS E1, I take data once an hour with this one, but it also brings my per point cost or per machine cost, and a machine analyzed by this means power quality coming in. It means the electric machine electrically and mechanically, the coupling, whether that's a belt or a direct coupling or a gearbox, and the driven equipment is 1 point. So it's not like vibration where I have to or should have 6 points on a machine, etc., etc., etc. So also that comes with it, because these all come calibrated, is the calibration sheet. Whatever your calibration program requires, usually these don't drift much, but you know, most places will do a year or so. That's all here, and it also comes with a USB that includes the software and the calibration file. You need that, and we'll go through that. We're going to do a complete setup. So let's go ahead and we'll start with this. This is the cord that plugs in. Okay, and there's 2 of them. So these are the cords that plug in. So only one required. Okay, and then we'll go through a quick E-plug. I already have one set up on the machine over here. This is what we're going to do continuous monitoring on for this test, this demonstration. So just plug it in. And therefore, I now have power. Everything's set up. Everything is there. There's no on-off switch. There is a fuse. That's it. There's a reset button, and the thing is ready to go. That's it. So if I lose power and it comes back up, this is already set. Now, an E-plug kit comes with penetration equipment so that you can come through a cabinet if you're doing data collection. We won't need that for this. It also comes with a couple of cords. We're going to use the longer one. That will connect from here. Okay. Never do that. Okay, so we will end up connecting that from here into one of the channels. We can pick any channel we want, okay, and I'll show you why. So I can pick any channel here that I wish. Let's go ahead and we will select channel 8 because I want to do, so randomly selected the channel. Okay, we're plugged in, and we will come over here. We're going to plug into the machine. That's all it takes. Okay, now that plugged into an E-plug. Now what an E-plug looks like is this. For those who are wondering, and I tell you, I have seen some of the other guys' stuff, and it's massive. This is an E-plug. That's it. 2.5, maybe just 2 3/4 by 7/8 tall, with a DIN rail mounting. The rest of this is cable. This will take up to 1,000 volts phase to phase, and my CT inputs here. Okay, so C1, C2, and C3. That's it. So not much, not something I have to be overly concerned about. Everything is rated appropriately. It follows a nuclear power specification, the whole thing. So that's it. We have now set this up. This is ready to go. We are in channel 8. So when we set up the machine, we are going to set this up as a box. I'll show you how to do that. Matter of fact, we're going to throw this one off, and we're not going to call it box 0. We're going to call it box 1. That's it. Now on to the next. Okay, now that we have the box set up, I've run one video and I've used 9.0, the beta, and now we're going to go ahead with the one that's already in place. Now this will help people who are already using the system, want to learn a little bit more about it or apply it. And let's go ahead. First thing we're going to do is take a look at what comes on the USB. So this is the USB. In here, you're going to find the calibration file. So in this case, we have this one here for the ECMS 32 box 81. Now this gets copied into the C Framatome folder when we set that up. Also in here, you're going to see the training manual, and then also the ECMS installation procedure, which is step-by-step what we're going to do. This is the iCal. We're going to want that because that's going to connect us up to our system. Now, I've already done this, but I'm going to walk you through it as well. And then the 8.0 whatever version, in this case that's E, we're going to use F. It's the same thing, but that's basically it. So we're going to walk through the setup of that machine we set up. I have it turned on already, so we'll be able to see that. I've collected some data in 9. So some of the stuff we've done is already there. So you go ahead and you do this, you walk through it. Depending on how your Windows protection is set up, it may warn you and and you just say okay and move forward. There's nothing wrong with the software, just a lot of protective stuff is a little more protective. The other things in here, I'm not clear. These must be okay. So this is a test on the 32. So there's data in there, and then this. Not sure why it has it in there. Yeah. All you need is the. So those are the Instacal CD stuff. That'll help with if you have somebody help you with calibration, I guess. But anyways, so the one that we're concerned about is this one here. So we're going to take, and you want to copy that, and you want to, after you've installed the software, go into your C folder and Framatome, and you can see that I have that in here. Now, you also see these box files. I have a lot of them. So there's 81 there. You also see all these USR files. The USR files are special text files used for mapping out different applications. You see these ones down here, those are data collectors of different types, and so on. So that's we're going to return to this at some point because there's things we're going to need in here, in particular the scheduler SCH. You also see this one called Watchdog that protects our system, and if for any reason the software locks up, it grabs it. So let's go ahead, and I have the software started. We're going to go through the setup. So, and we're going to take a look at this as well. So I've created a COM folder, and you can see I have other stuff in here. And as I talked about, we're going to call this one Box 1 and Channel 8. Now I can, under Box 1, I can have all 32 channels in there. So let's go ahead and then I would set up tests, and you can see I also underscored in between anywhere where I have spaces. I do that as a best practice. It's not required, but let's go ahead and we're going to first come in here and do setup options. So I come in here. First step is to select the calibration file, okay, and then go through here. And I want this to be 65,536 all the time. Everything should be checked. Don't worry about the A to D card. I usually leave that unchecked for continuous monitoring as well as a calibration warning. If for any reason this decides it wants to open up, everything freezes until you check a box. So, those two I leave undone. Analysis 65,536. Those can be checked. E2000. Check everything except for display unidentified peaks. This has to do with energy consumption and emissions. Make sure all these are checked. These you can modify the colors of each channel. EMP3, this gives me all of my alarm levels. Basically, minimum load to make a rotobar call, always leave that as, change that to 5. Don't leave it as 25. That's horrible. That allows you to look all the way along. So when I get here, you notice, how do I set up my other things? So Control-Alt-Enter pops up the hidden folder, and I click on that. Do not check Channel 7 and Channel 8. That is for accelerometers and the data collector. Mine has it. Down here, this is where your primary data will be set. So this is where it's saved to. That should be written directly to a drive. You don't want that saving to the cloud or anything else because you're streaming 12,000 samples per second for about a minute. And if you start glitching that, you're going to get a really bad resolution and really bad results. So you want that to be as close as you can. Usually, that's part of the reason why we supply a gateway computer. And then the second one, that'll send a copy of that either to the cloud, to your local PC where you're doing the work, to your server to save it, whatever. Now, so far as the computer goes, we usually ship these with a inexpensive gateway computer to act as a buffer between the device and what's being, between that device and a server. So if you're doing any monitoring or whatever else, it just provides a simple way of making sure that there's nothing weird that goes on. Faster installation, a little more secure. Some places want to spin up a drive. Perfectly fine. You can spin up a PC anytime you want and do it all from there. That's fine. You just have to be aware that when your system starts pinging the device when you connect it through your system, it's not going to respond. It's dead, meaning there's nothing there that is able to respond to that. So you have to have flooding protection in place, especially if you're using like a Cisco switch or something like that. Especially certain Cisco switches, you need to make sure that you turn on flood protection. Otherwise, you can overwhelm that switch. So that's part of the reason why we have that in between, because otherwise there'd have to be a brain in the box, and there isn't. That box is a multiplexer and a few other components. So that's all set. You want to set this for about $9.99. At 1,000, it's rolling over. First FIFO, basically, first in, first out. And then I usually leave this about, this is in the database itself, which is an MDB or an Access database for trending. So this will have 10,000 points of trending per machine. And then text file, basically the last 30 tests will have a will have a text file that can be looked at. Allow a second copy if I do that remote folder, and then leave all this stuff. The disable reboot at midnight. The software automatically restarts at midnight each day. That eliminates any type of errors that have been going on and just restarts it fresh and working off your data. Acquisition. Make sure that that those are selected, and 65.536 calibration warning should be off. Analysis 65.536, and we went through the rest. Okay, so we are set here. Click OK. We are now ready to start creating our system. So first thing is I would put in a motor, say test motor 2 or 3. Right, I did say I was going to do the best practice. Test motor 2. Okay, so it's the same motor. And check that box. It comes up here. And I'm doing this just so I can walk through the whole thing. We're going to use the first one there. So, so highlight it. Come up here to Happy Face. That opens up my nameplate. And here I have a selection of different types of equipment. We've reduced it a little bit because a lot of the same. I don't know why we still have VFD in there. Ignore that one. So if it's on a variable frequency drive and it's an induction motor, select induction motor. Synchronous motor, what it does is it won't call certain things. Transformer, I usually use that for continuous monitoring of power. But it will identify loose connections and the like. We've done that a number of times. I've got case studies out there on that, and so on. Generator is a typical generator, usually synchronous. DC equipment is motors and DC generators. And then finally, asynchronous generator are defig wind turbines. Okay. Number of phases 3. So we've got this set up to take in 3 phases of voltage and current. Let's come down here. This is the default. I'm going to say it operates 24/7. And let's say we're going to say pump, fan, or compressor. Let's say we have 7 blades on it. Okay, so I can set that up. Then it's looking at this and driven equipment. And if I want more detail on the driven equipment, I create a USR file for it. Under power, this is a 0.75, so don't worry, it can be a decimal. 1785, 230 volt. This one has 2.5 amps. Always want to set this as low as possible so that it won't accidentally think it's off. If I come here, motor database, if I click on this, it provides rotor bars and stator slots for about 8,400 machines. And I can come in here simply and say, okay, let's say Baldor. There's my Baldor. Let's say it's a 10 horsepower, etc. I can come in here. Notice that, same frame sizes, very, very similar when it's on the same speed. It gives you a hint. People don't like to reuse or make different stampings for different machines. So if it's the same frame size, they're going to try to use that. So remember those numbers. Don't just hit OK because it'll repopulate the work you've done. You can if you want, but in this case, that little motor has 28 rotor bars. 28 rotor bars and 36 stator slots. So I put that in. CT ratio 1:1. So we're taking direct measurements, totally enclosed fan cooled. It's in box 1. Remember I said box 1 and channel 8. There we go. I want the resolution to be 0.01 hertz. For continuous monitoring purposes, that makes it a little tighter. Possibly a few more positive, basically false negatives. But, for this purpose, I'm going to do that. The default is 0.02, which balances out false positives and negatives. And when I get away from that, I'll have more false positives. So you can leave it as the default or you can go there. We're going to leave it there. Test info, if I have a USR file, it's in here. Okay, but I don't want one, so we're going to leave that out. Bearing info, let's go ahead and open up the database. There'll be a pause while we do this. I might have to, depending, because it's got to reach into that database and pull the information. Oh, there it goes. Oh, okay. I'm going to have to just pause this for just a minute. For those of you who follow me, you know that the Camtasia, which is what I use for my stuff, tends to overwhelm this PC. So anyways, drive in 6304 bearing. So I do that, and then I select, and I'll say it's a ZZ. When I click OK, it populates the multipliers for that. And let's go ahead, and we're going to call the back one a 6204 as well. No, I'm sorry, it's 6203 2Z. Okay, so there's my bearings all set. Ignore list. I can go in there and select things that are nuisance or whatever. Down here where it says check for sufficient current draw before download. That's why we set that lower end to 0.1. Plant info, I can put that in there, and here's where I can put in these are instructions for this machine, or general notes, or whatever I want. Okay, and then if I want to attach a picture. So you can see that popped up there. Now, we're not going to use this particular machine, but let's go the next step in any case. Actually, we're going to do that for this one. So I can delete this. And while this is highlighted, next thing I want to do is come up here to this and make sure that all of my settings are correct. So the sensors I have are 10 millivolt per amp. This is for voltage. So I click OK. Let's do something in here because it's something I had to do. I don't know how it's going to turn out. But let's change this back to 1. It's a long story. Oh, and the other thing was I had changed this to 0.01 hertz, right? So there we go. And because we know this is lightly loaded, it's actually not loaded, it's just sitting there on a table. So I have all that stuff set up now. So, and I have my database thing set up. So the next step is for me to come in here and, go to the folder again and select schedule.exe, which it will should show nothing. That's why I'm checking it first. Okay, nothing there. I usually say make a shortcut or pin it to your taskbar. I'm going to do that right here. And then you can see nothing's here right now. So to change that, I'll come in here, right click, and you can see that it's got some stuff, right? I come down here and I say add and remove to ECMS list. Boom. You also notice down here, ECMS 320081 is there. So while I'm in here, let's go ahead and we will just see if we can see data. Yes, we can. And this is going to give me some problems. Look at that, 26. Yeah, it's done the same thing for some reason. It's giving me 10 times the voltage. So that, of course, is a little off. So we're going to go ahead and exit out of here. And let's change this back to what I had before, to 0.1. Now, there's other things I could do. We're just going to do it the simple way. So now, when I open up, this value should look a little more reasonable. There we go. That looks more like it. So about 265, etc. That's about right for the way I have this thing set up. Now that's reading off the peak voltage, right? So it's reading this and then it's giving me an RMS value, but you can see that's obviously pulse width modulation. So let's go ahead and we'll click on this. That sets the gains. And this will put everything roughly in order. And I want it to tell me what the power factor is when it comes up, and it's going to give me some stuff. I don't agree with that, so we'll do a bunch of other stuff, but let's go ahead. I'm just going to put them in line. For that, for this version of the software, I'll click. Okay. Which instead, I guess, just froze it. Let's do the gains again. F9 is supposed to put them in order. Just running into some stuff with the laptop. I ran into it when I was doing the other part of the demo on version 9. Okay, so here we go. We'll just accept that. So just for fun, what I'll do if I'm setting something up to make sure everything's right is I'll then download a set of data. So here we go. This will count out. You'll see there's a percentage complete down here and a timer here. This will go up to 48 seconds. You can see something occurred funky out here. I can just barely hear the computer in the other, or I'm sorry, the machine running in the other room. So let's see what it does. So, yeah, I had this value up. Shut that down. 40, 41, 42, 43. It's almost like watching paint dry. Okay. And now it's going to complete, and it's going to pop up a little calculator. It's going to adjust everything. It's running on a VFD, so this will all shift over. Should shift over. There we go. And it's going to tell me what it thinks it sees. Now I know that it's showing as overloaded. I know it's going to show basically greasing issue on the opposite drive end. We've talked about this in some of my case studies. You can see what happens with the air gap torque a little bit. But we'll walk through this real quick. So there's quick results. There's all of my information. It did correct after all for power factor. So that's there, the percentage overload, so on. Here's all the frequencies, including the running speed in hertz, the line frequency, and pole pass frequency. Bearing conditions, phasers, including any harmonics that are going on. That is harmonics related to the VFD. So that is what are generally, well, that's going to be within the 50th, but when I get into the second order and third order, that's super harmonics. Same thing in current. The actual amplitudes, and I could show different things there. Here, this is my all of the different conditions going on. This one here is calculated losses, and then torque is air gap torque in time and frequency. gives me certain capabilities. Running into larger machines is a little more fun. Print will always print just the graphics. It'll copy it to it'll copy it so I can paste it elsewhere. This is my report, and this populates the data into an Access database for for some trending, and so on. So all that is here. That is good. There's a bunch of other stuff I have capabilities of doing. That's a different tour. That is post-testing. Okay, so I now have everything set up. All the gains I've set and everything else are good. I've given you a very, very quick tour of some of its capabilities. If it had other problems, it would show it in detail. I've gone ahead and I believe I set it up for add remove to ECMS list. Do you want to remove it? No, I do not. So it's there. So now that I have that there, I can then reopen my schedule. Let's reopen my schedule. And it'll show. Now I have a history in there already. That's why I didn't want to delete anything and start over. So it's showing the previous tests. Okay, so from here, if I double click on this, I like mine a little bit bigger. There we go. I can set my schedule in here because I had shut everything down before. It's not selected anymore. We're going to do every 5 minutes. Okay, that's set. Click the checkbox. That's now ready. So the database is set up to write to. Up here, nuclear button, upper left. Press that in. Yes, we want to run it. And then it's pretty much set now. Now I can do a test run. Let's go ahead and do a test run. I'm going to click on that. Database status is okay. It's going to run the data. It's basically going to download data. Now while it's doing this, there we go. Just like before, it's going to run everything. It's going to pop everything up, and then it's going to update that. In the meantime, in here, while we're waiting for that to occur, it'll end up updating this graph. This is, machine learning. Oh, I'm sorry, it's AI. We're supposed to call it AI now, so it's AI. But anyways, it sets the average points in between and everything else. Bunch of other stuff I can do down here, including looking at those data sets I talked about before, and I can walk through them. It'll show the date and time, and I can see what's changed between data sets in both low and high frequency. Okay, that kind of thing. So that's what those files were for, the 30 files we set up. So it'll be 30 of those in there we can walk through. The data points, the existing data points are in here, so I can do, I can go in and find out anything, and that's for voltage. There's a pull-down list of all the things I can trend. So if I want to see what's changed, I can come through here, and it will give me a changed, there we go, graphs. It'll show me whatever the speed is. The speed's pretty constant because it's just sitting on the bench running. This will allow me to auto-scale everything. There we go. And so on. So this will erase any particular one. This changes so I can scale the time and so on. So all of that is here. This is continuous. It's going to update. Ignore that. That's because I'm messing around in here. But when the 0.01 was set, you can see compared to the other stuff, my peaks are going to be much, much sharper. This will all update. There we go. Boom. It updated. There's my data sets in there. That's the kill switch. That's that automatic thing. So it says that, oh, the RPM changed for some reason. What's happened with current? Oh, that's interesting to notice. So all of this is going on. It's also identifying, that it's vibrating. Yeah, I knew that. And then all that data is up here. The other thing that I didn't cover on and the report is basically on the last test. This would be what ends up printing out in the printed Word report. It will look prettier than this, but basically it's a lot of data that you can go look at. Up here is my email alerts, and this here is where that quote-unquote AI will alert you if you go outside of the parameters that it's used to seeing. You can also change the length of the reports to whatever you want. This is the certain other parameters. If I do a lot of changes, I can reset. So if I change this to a different folder, I click on reset. But in any case, I can enable email, and then there's a lot of setup involved. That go off the manual. I'm not going to do a demo of that. My computer's not set up for it. But that's it. This could be minimized and this could be running. So in the meantime, I need to turn this off. There we go. The kill switch is gone. And I am going to turn this off of being on ECMS. Yep. And it's removed from the list. Now I don't have anything showing up while I'm trying to run my data collector. But that's it. If you have any additional questions, let me know. As you can see, it's very, very simple to set up. There's a lot of other features in here that we didn't cover. It's a very, very powerful tool, and it's extremely accurate. So if you have any questions, reach out to info@motordoc. It's M as in Mary, OTOR, D as in David, OC.com with your questions. Thank you very much.